Good morning, friends. I hope everyone is doing well. I request everyone to watch my videos in a sequence for better understanding. In this video, I want to discuss how we can organize a CPU. We can organize the CPU in three ways. One is the using an accumulator. We will call them as a single accumulator organization. Using the general purpose registers, we can organize a CPU. Which one we will call it as a general purpose register organization, and the third one we can organize the CPU with the help of a stack. So that organization will call it as a stack organization. Before discussing about these three organization, let me discuss about the special purpose registers. Okay, we have a special purpose register called accumulator. In shortcut we will call it as an AC. Okay, and we have another special purpose register called program counter. In shortcut we will represent it as PC, and we have a instruction register. In shortcut we will call it as an IR, and we have a address register. In shortcut we will call it as an AR. Now let's take that I have a program P1 which consists of three instructions: instruction 1, instruction 2, instruction 3. Now it is a sequence of instructions will be executed, meaning is that there are no branch instructions are available. Meaning is that first instruction 1 will be executed, then instruction 2 will be executed, then instruction 3 will be executed. Now in that case, what is the special purpose registers consists of? Now the accumulator is a special purpose register which will store the temporary results, or even if you want to perform one address instruction, then it will be, the accumulator will be useful for you. Now coming to the program counter, the address of the next instruction. Let's take that currently you are executing instruction 1. Then the address of the next instruction I2 will be stored in the program counter. So the address of the next instruction will be stored in the program counter. Now the current instruction which is executing, instruction I1, let's take that it is add A. Okay, this is the instruction is there in the I1. Now that instruction will be stored in the instruction register. Now the address of the instruction I1 will be stored in the address register. Remember one thing, address of the current instruction which you are executing will be stored in the address register. The current instruction, what is that instruction? Like it will be having the instruction mode, it will have the opcode and the operands. All this will be stored in the instruction register, and you have a program counter which will be useful for us to store the address of the next instruction, and accumulator is useful for us to store the temporary results. Now with this one we will discuss about the single accumulator organization. Now single accumulator organization, we will have only accumulator and we will have the special purpose registers. Then how the instructions will be executed? Suppose let's take that you want to perform add A. Okay, like this is a one instruction. Using single accumulator instructions, we can perform two types of address instructions. One is that zero address instructions and one address instruction. What is meant by zero address instructions? In the earlier video I have discussed. We have four types of address instructions based on the number of operands. One is zero address instruction, one address instruction, two address instructions, and three address instructions. What is meant by zero address instructions? The number of operands in an instructions are zero, because every instruction will consist of three parts. One is the instruction mode, then the opcode and the operands. What is the use of operand? It will tell on which operands you want to perform the operation. The opcode will tell you what operation you want to perform. Let's take that if it is a zero address instruction, then meaning is that you will not have any operand. Okay, the number of operands in this instruction is 0. So that's why we'll call it as a zero address instruction. Now what is meant by one address instruction? If you have only one operand, then we will call it as a one address instruction. Now how it will be one address instructions will be executed is, if you will have an accumulator, we have discussed. So accumulator is equal to accumulator plus A. Now let's take that A is consists of the value 5. Is it clear? Are you able to understand? So this 5 will be added to the accumulator. Let's take that the accumulator is having the value 7. So 7 plus 5, 12 will be stored in the accumulator. So this is the way you will execute the instructions. Then you can ask me, sir, how can I execute the two address instructions? Is it only that I can perform only add A? If I want to perform add A comma B, meaning is that if I want to perform two address instructions. What is the meaning of add A comma B? You want to perform the summation between the operands between A and B. Now how you will perform? Using the single accumulator organization is that first you will push or load this B value into the accumulator, or you can do in another way also. Instead of loading that one, because you want to store the A value, because add A comma B is nothing but A is equal to A plus B. Am I right or wrong? So what you will do is that you will load the operand A into the accumulator. Is it clear? Accumulator consists of some value. You will load the operand A, means the value of the operand A, to the accumulator. Then if you perform accumulator is equal to accumulator plus B, then it is nothing but A is equal to A plus B, because you have loaded the operand A value to the accumulator. So you can perform even the two address instructions indirectly by using a single accumulator organization. So I hope you have understood what is a single accumulator organization. We will have only accumulator and the special purpose registers. Now we will discuss about the general purpose registers. We have two types of registers will be there. One is general purpose registers and another one is the special purpose registers. Already we have discussed about the special purpose registers. Now what is the general purpose registers is, this we will represent as R1, R2, R3, so on like that. Now this will consist of some values, like you can store, suppose if you want to perform add A comma B. Okay, then now remember one thing. What is the use of this general purpose registers is, let's take that if you want to perform add A comma B. A is one operand and B is another operand. If you want to fetch from the memory, because A and B values are there in the main memory. So remember one thing. Let's take that the main memory is 1 MB. Okay. Registers are some 16-bit registers. You have, let's take that 4 registers are there. Are you able to understand? If you have 4 registers, how many bits are required to represent or identify one of the register? You need 2 bits. Am I right? If you have 4 registers, you need only 2 bits to identify the one of the register. If you have 1 MB of the main memory, meaning is that you have 1 MB of words are there, means 1 M words are there. Is it clear? Are you able to understand it or not? Then how many bits are required to identify one of the word is that you need 2 power 20 bits are required. So your address will consist of 20 bits. Are you able to understand? So whether is it easy to search it in the memory or easy to search it in the using the registers? Because if the address is 2 bits, then it is easy to fetch. And even remember one thing, we have already discussed about the memory hierarchy. The fastest one is the registers, then the cache memory, then the main memory. So it is very easy for us to fetch from the registers as compared to the main memory. So that's why what we will do is that the CPU, if you want to perform add A comma B, the A value, the operand A value will be stored in some general purpose registers. Okay, and B operand value will be stored in another general purpose registers. Then we will write it as add R1 comma R2. Meaning is that R1 is equal to R1 plus R2, where R1 and R2 are the 2 general purpose registers. Are you able to understand? So these kind of instructions can be performed using the general purpose registers. So this is what kind of instruction it is. It is a two address instruction because we have two operands are there. Can we perform the three address instructions using general purpose registers? Yes, we can do it. Let's take that sub R1 comma R2 comma R3. Then it is nothing but R1 is equal to R2 minus R3. Okay, the value which is there in the register R2 minus the value which is there in the register R3 will be performed and the result will be stored in the register R1. So this is about the general purpose register organization. Okay, we can perform the two address instructions and three address instructions using the general purpose register organization. Coming to the stack organization, we will have a stack. Okay, and using the stack we can perform the operation. So now how you can perform, suppose if you want to perform add a comma b, then how you will perform is first you will push the a onto the stack and you will push the b into the stack and you will perform the instruction called add, which is a zero address instruction because the number of operands are here is 0. Is it clear? So we will call it as a zero address instruction. So what will happen? It will perform a is equal to a plus b, or nothing but it will perform the a plus b operation because the top element is b and the next element is a. Between these two elements the addition will be performed. Okay, so we can perform the zero address instructions using the stack organization. Okay, I hope everyone know what is a stack. We can perform the push operations, we can perform the pop. Meaning is that push is what? Inserting elements into the stack. Pop is what? Deleting the element from the stack. And stack is what? First in last out operation. Meaning is that whatever the element you have pushed first, you can pop it at the last. So this is about the various types of CPU organizations. I hope you have understood what is the single accumulator organization, general purpose register organization, stack organization. If you have any doubts related to this video, feel free to ask me in the comment section. I will clear your doubts in less than 24 hours. Thank you for watching my videos. Have a nice day.